Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. Once again, we are going to try to take a look at Comet Atlas. So, for the next couple of minutes, ignore all the colorful pixels on the screen. Those are hot pixels. That's normal in a CCD like this. Those will be removed by an automatic dark frame in just a few minutes. I ran a single 1 minute exposure on the comet, and you can barely even see it in the view. It is right around here by the look of it. Right around there. Not much to see. So hopefully 2 minute exposure will brighten things up a little bit. There are reports that the comet is fragmenting, and that there are distinct fragments visible. So we will see what we see when we take these pictures. I'm going to wait for the auto dark to take. The comet is very faint, but it's right there. Very faint. If it's too faint, then I might go to more extreme methods of using Deep Sky Stacker Live and at least previewing the latest image and just cranking the heck out of the contrast on it. Just sacrifice the quality of the image in order to get enough visibility on the comet. We'll see. So, yeah, there are pretty clear pictures now of it fragmenting from various amateur telescopes and professional telescopes. There do appear to be pieces of it visible. But let me put to bed the notions that any of those pieces could hit Earth. I've seen separation velocities quoted as being quite high at 13 meters per second. But that is a snail's pace compared to what would be needed to send any of those pieces to Earth. Like 1,000 times too slow. So, no, there's no risk of any fragments hitting Earth. But it will be interesting to see if we can detect those fragments, and maybe I can track them separately and calculate an orbit for them and compare them to the orbit of the comet itself. We'll see. Alright, so it's almost done with the automatic dark frame. Downloading that now. That'll take care of the hot pixels and hopefully bring us more contrast on the comet. Yeah, okay. Not a whole lot to see there. Wow. I'm telling you guys, this comet is just the worst. It's just so faint. It's just so faint. I swear it's getting dimmer every time I look at it. And people are saying, oh no, it's fine. The comet's fine. I don't see any evidence of problems with the comet. Well, now we have pretty clear images. I'll share one of them on stream from a couple nights ago. Great Shepherd Observatory took this picture I'm going to share. And let me tell you, it's pretty clear evidence of fragmentation. I use Great Shepherd Observatory's observations all the time when I'm wanting to look at amateur astrometry for calculating orbits and exclude all professional sources, just to show that no, the professionals aren't lying. This asteroid, whatever it is not going to hit Earth. Great Shepherd is a very reliable observatory for getting high-quality astrometry, in my experience. Amateur independent astrometry. So, I'm going to... Okay, fine. I'm going to see if I can pull this image up on the stream. Just gotta find it here. Come on. There it is. Okay, that was not it. That was someone else's picture. Let me try. I'm having the worst time tonight. Let me try again, see if I can find the right picture. I forget whose picture that was. That was another amateur picture. It also showed fragmentation, but it wasn't as close up. So it was a little harder to see. Okay. This one's got to be it, I guess. There we go. There, a lot clearer, a lot better, easier to see. You can see the fragment there in front of the main part of the nucleus, which itself is extremely elongated there. I mean, it's a stream. It's not a real clear, intact comet. Now, in my images, the comet is barely even above the noise level of the image. And we don't have a moon out yet tonight. This is dark skies. Now, astronomical twilight is in about 4 minutes, so maybe the sky will get slightly darker, but not by much. And this comet is just not a super good, healthy comet. And yeah, it's nice and clear here tonight. Forecast calls for clear skies throughout the night. We'll see if that holds true. But clear for the moment. So, happy Easter, everybody. Glad I could bring you this stream tonight. We'll see what happens here. Like, there's a faint little something up here. Maybe that's the fragment. Maybe this is the nucleus. It's hard to say. You know, these images are very marginal for the detection of the comet. I could go to 2x2 binning, which will make these images grayscale, but also allow these images to bend together pixels and maybe bring out more detail. Right now, the image scale is 3/4 of an arcsecond per pixel, 0.75 arcseconds per pixel. It's pretty close up, and I thought I might need that resolution to distinguish any fragments from the nucleus. I'm now kind of regretting not putting the focal reducer between the camera and the telescope. But we can experiment with that. Nope, whatever that was up there didn't stay around. But there does seem to be something there. Alright, I'm going to turn off Great Shepherd's picture here. Good picture there, the nucleus and the fragment. Okay. Oh man, yeah, this comet is like barely visible in my images, and I was thinking that was what was going to happen. As soon as reports came out that this thing's disintegrating and I started taking pictures again of it, I could tell right away it was not as bright as it was before, and to my eye it looks like it's declining night by night. But if you have a wider field telescope, if you're not as zoomed in as this, the photons of the comet are coming from, well, on each pixel, you're covering more of the comet, so the signal-to-noise ratio there in your image stands to be better. That's why I'm thinking of binning it 2x2 to increase sensitivity here. You know, if I was using a wider angle telescope, I probably wouldn't have as much trouble getting the comet nice and bright in the images. But at this scale, at 0.75 arcseconds per pixel, zoomed in all the way like this, we're having a heck of a time trying to see the comet real bright. It's just not easy. Okay, I'm gonna try something silly here. I'm gonna stop the auto guider for a second. I'm going to stop the images for a second. And I'm going to call this 2x. We're going to go 2x2 binning, which is silly. We're going to lose the color data, but hopefully gain sensitivity. Okay, the auto guider is running again. Alright, so we're going to take a 2x2 image. This will cut the resolution in half and kill the color data, so this will be a grayscale image. But I'm curious to see what happens with the comet's appearance, if we can see more detail and just plain see it better against the sky glow. What does binning mean? It means that the pixels, you can picture them like buckets, okay? And we're taking the pixels and taking them 2x2 and combining them into a single pixel that's twice as big. That's kind of the short and sweet version of it. It's not just averaging two pixels together, it's actually combining the signals of two pixels on the chip. So it actually gains sensitivity because the read noise should still be the same, but you're combining the signal of two pixels. I believe that's true anyway, in terms of the read noise versus the signal on the pixel. But that's maybe getting down into the weeds too much. Short and sweet is it enhances your sensitivity at the expense of resolution. And in the case of the single shot color camera, you can no longer get the color data out of the image. I saw it better the other night, someone else's channel in Germany. Well, that may be true, but that might be because I'm using such a close-up pixel scale here. And if we find that at 2x2 it's a lot easier to see what's going on, I might opt to throw the focal reducer on there. I'll have to refocus the scope and all that fun stuff, recalibrate the auto guider, which, by the way, there's not a very good guide star tonight at this scale. Okay, so you can see the comet a lot better there, that's for sure. But we'll see what happens after the auto dark here. Can I image C2019 Y1 Atlas as well? I'm thinking probably not. Because where is that? No, that's 7 degrees above my horizon right now. And dropping. No, C2019 Y1 definitely not possible. Sorry. Yeah, it's done in the hardware at the CCD level. This is a color CCD, and there's a 4-pixel array to get the color: 2 green, 1 red, 1 blue on this CCD to get the color data. But you're just sacrificing that. Of course, the color filters are still there, but you're binning the pixels 2x2, so the color data is no longer meaningful. You know, you might be binning a green with a red pixel or a green with a blue pixel, so the color data doesn't mean anything anymore, which is why it's a grayscale image. Will it hit Earth? No, definitely not. Neither will the fragments. But I would like to be able to see the fragments, so Let's see what we get here. I can also play around with the contrast of these grayscale images in real time on this program a lot easier than I can with the color images. Okay, so there is that. Turn off auto contrast. And actually I need to abort the image. I need to reset it for that setting to actually take. Okay. Okay. So I don't see clear signs of a fragment necessarily, unless this is something that's fragmented, but we'll see if it moves. I doubt it. That's probably a background star. Yeah, sorry to disappoint you, I guess, but it's not hitting Earth. Let's see, I'm really curious on this next image to see if anything other than this streak of the comet moves. Like that little guy there or anything else stays around and moves with the comet. If it does, then I'm going to be real tempted to throw the focal reducer on here, even if it means resetting things a bit. Let's see, what's the comet's altitude at? 43 degrees, so we still got some time. Yeah, let's see what happens. It's a real tough choice, You know, even if I don't see any fragments here at this scale, I'd still be tempted to throw the focal reducer on and see what we get, because it's sort of like going to be a... Whatever that was isn't there now. That was probably just random noise. Real tough to distinguish random noise from actual comet here. This could be... There could be separation there between that and that, but hard to say. The only thing I'll say for sure is in my view, this comet is not brightening. It's continuing to decrease in brightness. It's getting harder and harder to get images of this comet. Did I get that control cable fixed? No, not yet. The declination cable still needs to be fixed. Haven't gotten around to that yet. I'm just trusting that it's not going to fail. What is the time delay with Atlas? Ooh, good question. Time delay is currently 8.36 minutes. go. Next picture. Yeah, I don't see any clear signs of fragments here. Alright, much as I hate to do it, I'm going to take a pause on this, and we'll throw the focal reducer on and see what we get. We're just going to keep trying strategies here to improve the view and see any distinguishable fragments. Alright, so bear with me for a few minutes. I'm going to have to disconnect the camera from the telescope, throw in the focal reducer, reconnect the camera to the telescope, then I'll have to refocus, recalibrate, and get back on the Comet. And I'm going to try to make all of that happen as quickly as possible. Alright, so I've already got the camera on the focal reducer, and now I'm just recalibrating the auto guider, and then the adaptive optics unit, and then we will move to a star close to the comet, check the focus one more time, make sure it's fully focused, and then move on to the comet again and try this one more time, this time with the focal reducer. So, let's see what we get here. Okay, drive calibration successful. Now I gotta fix this. Calibrate the adaptive optics. So, after we calibrate the adaptive optics, we will move to a different star. I should pull up those coordinates now. I'm trying to make all this happen quickly as I can. Okay, let's go there. Okay, I got the coordinates. Alright, we're ready. Okay, we're good on that. Let's go ahead and check focus. Imager, we're going to do 2x2, that's fine. Take a picture. Okay, cool. Our focus star's right here. We're going to zoom in on that. Go to 1x1 binning. I did this earlier, and it took a 5-second picture to start to get the diffraction spikes real good on it at 1x1 binning. Okay, needs a little tweak. Let me see if I can do that. I think that was a good direction. Give it just one more nudge. Let's see what we get. It's probably going to be shaking on this one. Oh, no, actually. Okay. That looks pretty good. Gosh, maybe just a smidge more. Yeah. I gave it just the tiniest nudge imaginable. Okay, that's good. That's pretty symmetrical right there. Okay, we'll call that well enough. Now it's time to go back to the comet. Okay. Let's see what we have to work with here. We have a brighter guide star now, thanks to the focal reducer. So we should be able to see a pretty easy guide star. Oh, no, I don't want a full second. Okay, there's a pretty good guide star there, as expected. Move it this way a bit. Should be able to get it with even 0.4. So we're going to try to center up this guide star a little bit here, as that will put the comet in a good position. Come on, come on. Alright, that's good enough. Doesn't need to be absolutely perfect here. Okay, this is going to be with focal reducer. And we're going to take... Let's go ahead and start auto-guiding. Let's see if we can get away with 0.2 seconds. Oh yeah, easy. Okay, we are going to set this to not subframe, 2-minute exposures. Let's go ahead and do that. Alright, we'll see what we get here with 2-minute exposures on the Comet while auto-guiding and with the focal reducer. So this is a 0.65 focal reducer. So we're looking now with 2/3 the magnification we had when we started with the color images. So a little more zoomed in than the grayscale images, but hopefully more sensitive than the color images. Hoping for a nice balance here between sensitivity and field of view. This is basically as far out as I can zoom the camera, though. And I can go to 2x2 binning on this for enhanced sensitivity with the focal reducer. That should really make the Comet pop, but I don't know if we'll be able to see fragments or not, even at that. We can definitely take a look for it. Let's see what we get first with the color images, and then go from there. Could even leave it up to the chat, maybe have you guys vote what you want me to do. Yeah, I don't think the fragments will survive their sun grays at 2 million kilometers. That's very close. Yeah, 1 sec. I kind of inclined to agree. I don't know that the fragments will really survive perihelion. Maybe the main core, whatever's left of it, maybe. I won't rule that possibility out, but I'm continuing to be... I continue to feel that the Comet is proving me right over time, rather than proving me wrong. I mean, yes, it's still there, but it's not brightening up, as far as I can tell. Maybe overall brightness is, though. Maybe the Comet's extent is growing, and the residual light of the extended Comet is having a net gain over time. That's interesting. Okay. So the Comet is perhaps easier to see here. It's near the center of the view. I'm going to try and move this down can scoot this whole thing down like that. Okay. That way I can keep the autoguider in view, but also keep the comet in view. You know, there's a little... I mean, it almost looks like there might be a dark separation within this streak of the comet, but it's hard to say. That could be, again, this could be random noise. It's really easy to fool yourself when you have something that's just above the noise floor of the camera. But it's a nice picture anyway. I mean, the stars are nice and tight. Looks to be well focused. Let's make sure we are saving these images. Okay. All right, here comes the auto dark. Okay. Yeah, we'll see what we get here. I'm inclined to leave it at this magnification for now. I don't think going to 2x2 binning is going to be beneficial, because I think at that point we lose so much resolution at this scale that even if there were a fragment, we wouldn't see it. It would all be merged into one blob of the comet. Thank you, Angika. I think this comet is disappearing before our very eyes. Yeah, I get that feeling. I mean, I'm guessing you guys do too, because you've seen my previous webcast, right? Most here are regulars who've seen my previous webcast. If you haven't, go check it out. The comet was brighter before. It's undeniable. And yes, the music is Stellar Drone. Sorry, I didn't mention that earlier. But this comet's minimum orbit intersect distance, I've said this a million times, is more than half the distance to the Sun, just about 2/3 the distance to the Sun. So that means its orbit does not intersect our orbit. The fragments will generally continue along the same path as the original comet. They might be spread out a bit along that orbit, but that orbit doesn't intersect our orbit, so there's no way that a fragment, no matter how delayed or how advanced of the comet, it cannot hit us. And plane change maneuvers are famously very expensive, delta V wise. The velocity needed to change your orbital plane is very high, especially for a comet moving this fast. So trying to divert a fragment to an impact trajectory would take a lot of velocity. Probably about 1,000 times more than any fragmentary separation here. But speaking of fragments, I almost do see a slight bump at the front of this comet that is slightly separated from the rest of the comet. You see that? That might be a fragment. Hard to say. Could just be random noise. But now for a couple of images I've noticed that there does seem to maybe be a little bit of a fragment there. So maybe this is the magic image scale that will get the job done and give us the best possible image of the comet. Of course, stacking the images at the end will make a bit of a difference and hopefully bring out more detail. But that's what we're going for here, trying to bring out any tenuous details to see any hint of fragmentation of this comet. And I think we're starting to see it in these images. So I can try to zoom in on that. Blow up the image a little bit. I don't know how that's coming across on the stream, but it looks like you can see this little darker line here between something out front on the comet and something behind here. So I think we might be seeing some hint of fragmentation there. It'll really have to be decided by the stacking of these images. And I know I'm a little behind on stacking images from the previous webcast. I haven't done that yet. But it's quick and easy to do with my new software, so I'll probably just do that all at once with these images and put them into a time-lapse video. Another time-lapse video, I should say. Joseph Buchanan says, that fragment you are seeing seems consistent with some of the images and reports I've seen on cloudy nights. Thanks, I kind of agree. It's real hard to say, but it does seem like maybe there's a little bit of a hint of a brighter spot out front on the comet, or a little separated from the rest of it. And that would be consistent with other images I've seen as well on Comets ML. So that's why I'm thinking that might actually be true detail there, not just random fluctuations of the camera. Yeah, see the stacking live as more data are acquired. I agree, Peter. Maybe that's a thought for future capabilities of it. The trick is that the images need to be astrometrically solved before I run them through my software. My software depends on solved images going into it. So I'd have to throw that into the pipeline to do it in real time. Not impossible, but a little trickier for sure. It's a complication I'd have to work out. I have some ideas of maybe how that could happen, but we'll have to see. Probably it won't totally disintegrate. Well, that may very well be, but it's definitely not the comet it once was, I would say. It was much easier to see in images that I took weeks ago compared to now. Is this the new iPhone? No, this is definitely not an iPhone camera. This is an SBIG ST2000 XCM with an SBIG A07 adaptive optics unit. And yes, I am looking at a pixelated image. I'm deliberately trying to zoom in on it to see whatever faint detail I can, especially with YouTube streaming and compression. I'm trying to fight that by zooming in too much a little bit so that the image compression that YouTube experiences doesn't completely ruin our view. But yeah, it's hard to say. It could just be my imagination. We'll see. Maybe in the stacked image it just looks like an intact comet, even though we know it's not from other images. But those images were generally taken with larger telescopes than what I'm using tonight. This is an 8-inch LX200 Schmidt Cassegrain on its standard mount, standard wedge, polar aligned, but it's just an 8-inch Schmidt Cassegrain. It's not as big as some of these other scopes taking pictures. And yeah, the iPhone could only dream of getting faint images like this. Very true. In all seriousness, what's a camera like this cost? Well, the original retail price for this camera, not what I paid for it, but the original retail price, was about $3,000. The adaptive optics unit would run you another $1,500 to $2,000. So in total, you're looking at about $4,500 to $5,000 of camera equipment. That's before the telescope. But in practice these days, you can get this equipment much, much cheaper on the used market. And yeah, an iPhone, not only is it probably not capable of 2-minute exposures out of the box, but it's also definitely not got a guide chip. This telescope's camera has a built-in auto-guide chip that's guiding on this star very rapidly to keep all the stars perfectly centered, perfectly sharp in the view. And it's also got an adaptive optics unit attached to it, literally bolted to the camera because it's designed to handle that. And that has a tilt-tip mirror that is moving to keep that star perfectly centered much faster than the drives of the telescope could even respond. So it's able to compensate for all of the guiding error and even to some degree the atmosphere. But yeah, I would say, based on these images and comparing it to previous nights, this comet's trajectory is generally downward, and I'm not holding my breath for even being able to see it after perihelion. And no, the comet is not a threat to Earth at all. I know some people are worried about the tail hitting Earth, or the Earth flying through the tail of the comet. Well, that's not really something to worry about in the first place, but the tail is not going to be pointed at Earth anyway. The tail points away from the sun, and there is no time where the comet is between us and the sun. It will actually point in the general direction of Mars at perihelion, but we don't even know if the comet's going to survive that long. And yeah, the SBIG cameras are very nice cameras for amateurs. These are pretty high-end deep space cameras. I actually have two of these. I've got two of the same SBIG camera, because I thought this one was having trouble, and it wasn't. It was actually due to an incompatibility with Windows 10. So I went ahead and found another one on the used market, got it for even less than I got this one. I picked it up for like $400. I mean, that's just dirt cheap, really, compared to the original retail price. And it's in good working order. It didn't come with all the cables and stuff, but I didn't need it to, because I've already got the cables for it. I just needed the camera. So I've got two of these camera bodies, and I keep the other one just on its own, so I don't even really tend to take off the adaptive optics unit now. If I don't want the adaptive optics unit on there, I'll just use the other camera, my spare. But that was the problem I ran into when doing the Bepi Colombo webcast. I was running on the spare camera, and I hadn't changed out the desiccant in a while. So that's now done, and this one is obviously in good shape, which is why I'm able to chill it down to -5°C. There's an SBIG camera that's $35,000. I'm not surprised. So the main big three I can think of in the the amateur market for high-end deep space cameras would be SBIG, what's the other one? FPI Proline, I think, something like that, and then ZWO. You also have Attic. They make some good cameras, and there's one other I'm forgetting. It'll come to me later. But yeah, there's a few brands of very nice deep space cameras out there, and you can get up to very high prices on some of them. I mean, more than a luxury car in some cases. You see no breakup at all. Well, this comet is much more diffuse and much fainter than it was before. There was a very clear condensed nucleus on this comet before, if you look at my previous webcasts. It's now much more diffuse. And like I showed earlier, there are images showing very clear signs of fragmentation. Again, I'll show another image captured by another amateur recently for comparison. And as you can see, this one's going to be a much longer total integration time, probably a stacked image. Okay, but if I zoom in on this, what you see very clearly is there is fragmentation. I mean, it's really undeniable. Look at that. You see that? That's not an intact nucleus there. There are pieces. You know, I wish I could zoom in even more on this here. So this is, you know, a final stacked image by the look of it. But you can very clearly see that that nucleus is not intact. There are little fragments coming off of it there. So, no, this comet is not healthy. Yeah, that pic shows it really clear. And will this comet asteroid hit Earth? No. This is a comet, and it will not hit Earth. I know there's a lot of people saying that. There's a lot of fearmongers on YouTube. Sadly, they do make a lot of money doing that. I mean, it's just the nature of the beast. When people hear terrible news like that, if it bleeds, it leads. And so it gets eyeballs, gets people to watch. And as a result, those guys get a lot of ad money from doing that. Not to mention any kickbacks from sponsorships they might have with survival companies, selling bunkers or food or whatever. That's been the scam for years now. So, yeah, that's just how it goes. But no, there's no risk to Earth from this comet, even with the fragmentation. Those fragments don't have the velocity it would take to get to Earth. They would have to be traveling about 1,000 times faster relative to the original comet, and they'd have to be headed this way. And they're just not. We are going to take a look at another object, an asteroid, that will be flying much closer to Earth than this comet. This comet's closest approach to Earth is going to be about 3/4 the distance to the Sun, about 0.78 astronomical units, if I remember right, versus this asteroid that's going to get within about 16 times the distance to the Moon, roughly, a little more than 16 times the distance to the Moon. That'll be asteroid 1998 OR2. It's a rock about 2 kilometers in size. If it hit Earth, it would be very bad news, but fortunately it will not be hitting Earth. It was discovered 22 years ago, and I'll be tracking it again tonight, and with that I should have enough data to independently solve for the orbit and show it myself, show whether or not it's a risk to impact Earth, using nothing but my own observations. So you can independently confirm these things and see for yourself whether or not they are risks to hit Earth. So it looks like the comet's going to fly right by this star right here. I'm kind of curious what star that is. Alright, according to Sky Safari Pro, oh my. Yeah, that's a mouthful of long designation here. Alright, I'm going to try to read this off real quick, data style here. It is Gaia 11041727023809936664. Just rolls off the tongue, doesn't it? That's the Gaia designation for the star that the comet is about to fly right by. SlickX says, I've got a cheap Tasco reflector 3.5-inch telescope. It's okay to see the moon, but if I were to upgrade, what things should I be looking for? I would like to add a camera to it. Well, that's going to require a pretty significant upgrade if you want to get into photography, particularly deep space photography like this. I honestly feel sometimes like I'm running with the bare bones of what is needed to do this kind of work. But it does the job very well with this combination of equipment, and it's taken me quite a while to figure it out in terms of optimizing all of it and getting it to work reliably night after night, where it will track perfectly and give you nice, tight stars like this, where you're not seeing oblong stars from poor tracking. And so what I have is an 8-inch LX200 Classic. A modern LX200 will work as well. And I've got it on a wedge. So that's an equatorial wedge that allows you to polar align the telescope. And then the camera, which I mentioned before, is an SBIG ST2000XCM. And the A07 adaptive optics unit really does help a lot. It really has solved all the issues, all the residual issues I had with auto-guiding and trying to accurately track objects like this. Wow, that comet is almost indistinguishable from the star at this point. So, with this, you could get just to give you an idea of on the used market what you could do and how much money you're going to need, you could get a used LX200 Classic like this for about $1,200, I would say, on the used market in good condition. You could even pick up a newer GPS model LX200 for probably about $1,500 on the used market, depending on the age of it and all that. The SBIG camera, you can get, like I said, I got one of them for $400, but it didn't quite come with all the cables. It was missing some stuff. It also didn't come with the software. I mean, it was really bare bones. It was pretty much just the camera body, so you're going to need more than that. But if you spend $700, you could get an ST2000 in good condition. with all of the equipment it needs. And then for another, I picked up the A07 for like $100, I think, off Astromart. So for about $800 in cameras and another $1,200 to $1,500 in scope, you could be looking a little over $2,000. That will get you this kind of setup that will let you track these objects very carefully and accurately with the autoguider. Now, if you want to just do lunar planetary photography, that's a lot easier to do. The cameras there can still get quite expensive if they're very high quality, but you can start out with much cheaper equipment. Orion star shoots, this kind of thing. They used to make a thing called Next Image. I don't know if they still even make that. I'm kind of behind the times on that stuff. But there are pretty affordable planetary cameras out there that you can get to take pictures of Jupiter, Saturn, the Moon, with scopes that aren't this high end. You could get a basic Nexstar scope, like a 4, 6, or 8 inch SE, for a few $100, and get going with lunar planetary imaging. But that's not necessarily going to be high quality enough to do this kind of deep space work necessarily. For that, you're going to want something a little bit better. And a lot of guys would recommend you get a German equatorial mount instead of a wedge like this with the fork arms of a Schmidt-Cassegrain. It is a more direct route and probably more stable for doing polar alignment. A CGE Pro, for example, would be a good beginner mount for that. I don't know what those run these days on the used or new market, but it would probably be comparable in price, to be honest. You do have to polar align those scopes every night, though. At least here I've got the option, which I do like, of out-as aligning it, so you just mount it directly on the tripod. That is faster, easier to do, faster, and potentially more stable for doing high-speed tracking of satellites and rockets and things like that. That's why I would never ever trade this scope. It's capable of doing both worlds. Doing high-speed tracking of rockets and satellites and things like that on a pretty stable mount with the out-as mode. You can do satellite tracking with a German equatorial mount, but when the motors are turning at high speed, you really do want really high speed to be able to keep up with some of these rocket launches and stuff. And doing that off a German equatorial mount is not ideal. It can do satellites pretty well, but really even there you're probably going to want a higher end mount, I would think, for high stability to get the best views with a German equatorial mount. But there are pretty serious satellite trackers out there who do use high-end German equatorial mounts to do their work. But nevertheless, at this price level, I would say this scope is the best for that kind of job. So you may decide you would rather go with a polar, just a dedicated polar mount, a German equatorial mount. It would probably be more stable and better suited for this task. However, with the adaptive optics unit, the A07, it basically eliminates any tracking error from the mount. This mount's not supposed to be capable of doing these long exposures at the focal lengths we were looking at to start with. Without the focal reducer on there, you're at 2 meters of focal length, and this mount is famously bad for imaging at those focal lengths. It is not known to be tracking-wise, it's not known to be accurate enough to do that. You would normally get oblong stars, and the stars would not be nice and tight circles, even with auto-guiding. The autoguider is just not going to be fast enough to compensate for the amount of error that the mount normally has, because the gears on the mount are mass-produced and they're not that great, and so if they're not perfectly circular, sometimes the mount will track faster or slower than it should, and it takes it a while for it to catch up and fix itself based on the autoguider input. The tilt-tip mirror of the adaptive optics unit is much, much faster and more accurate, and can instantly respond to any issues there. The only real disadvantage to it is that in order to do its job well enough, you need a bright guide star. So you have to rotate the camera to find a suitably bright guide star. Magnitude 10 is like where it starts to get a little dicey. You end up needing full second exposures on the guide star, which you can see how fast the autoguider is going here, exposing the light. It's just hitting that bar, multiple times a second. And that's where it gets really good, because it's guiding right now at 4.5 hertz, so it's making 4.5 corrections per second to the position of that guide star using that tilt tip mirror. That is so fast that basically the mount is good enough that everything works perfectly. It's acting like a mount that is much more expensive than it is. The images come out much better than they should. Normally you would need something like a CGE Pro or something like that, a really high quality, even CGE Pro is not super high quality, but it's decent. You would need something like that to even think about doing this kind of imaging with a high focal length instrument. You can get away with a lot more with less focal length if you put a refractor on, a wide field refractor, and that's another option to go if you want to go with a setup that's not going to break the bank. The better option might be if you're not requiring this kind of focal length, you could go with start off with like an Orion ED 80 millimeter refractor and throw that on a CG Pro or something. That CG Pro will be more than you need perhaps for that refractor, but the advantage is you're basically future proofing. You can put a bigger scope on it later. You can start off with a smaller scope. So the Orion ED80 will probably run you $500-600 maybe for the tube, and so that's another option because it's more forgiving, easier learning curve on that. Yeah, so that's probably more than you wanted to know. I think I've been bloviating long enough about astrophotography setups. I mean, that's a whole huge field of discussion, I guess, but that's just my opinions, and my opinions are probably not the mainstream when it comes to amateur astrophotography. A lot of guys will tell you, "Oh, don't fool around with that Schmidt-Cassegrain on a fork mount stuff. That's ridiculous." But I like it. I think it works well. But you do have to use the right equipment. If I were trying to do this with an SLR camera and no autoguider, or even an autoguider that's just mounted on a guide scope, and I'm using the motors of the telescope to try to keep it centered, I've done that. I've been down that road, and that's a dead end with this scope. It's a path to much frustration night after night, trying to get the mount to work right and not give you oblong stars. Try to get nice tight round stars. It's just a path to frustration. But with this, it's so nice. It's stress-free. It works. It just works with the A07, as long as you get a bright enough guide star like I've got right now. And Mark says, so what you are saying is that my 80s vintage Meade 323 on its original EQ mount wouldn't be up to the task? Well, that almost sounds like a fun video right there. Would be to take one of these old school 80s Meade telescopes that don't even have go-to capability and just a basic clock drive, and slap an A07 on it and see what it does. As long as it's got some motors for auto guiding, as long as it's got auto guiding capability. Some of these old vintage telescopes had an auto guiding port on them, but not necessarily go-to capability. They didn't have a computer that could move to objects automatically, so it would still be frustrating trying to find your object on using just setting circles. Hopefully it's got, I don't know if that model even has digital setting circles or motors at all, but if it's got motors for auto guiding and if it had digital setting circles, that would make things easier. Maybe an LX50, I think. Gosh, I'm trying to remember. Did the LX50 have digital setting circles? It might have. So digital setting circles, for those who don't know, are like the encoders that my telescope uses to do the auto the go-to capability, where the telescope will go to objects automatically based on coordinates you put into it. Even if you don't have motors to turn the telescope to make it go, you can have what they call push-to capability, where, and this is quite old school, I don't think they really do this anymore, what they call digital setting circles, where they have the encoders that measure how much the telescope is moved in each direction. And it's got those measuring devices on it so that you can center it up on a couple of stars and tell it, you're now pointed at this star, and then it will tell you, okay, I know where you are in the sky now, here's your current coordinates. So you can get a constant readout of the current coordinates, and you can push it manually to the right coordinates to get your object in there. That makes things easier than physical setting circles, in my opinion. But that's a very old school way of doing things. I think the LX50, I want to say it had that capability, and it also had motors both in the right ascension and declination axis. So you could theoretically set up an LX50 with this kind of camera in AO7. I'd be really curious to see what it does with that, if it's capable of producing the same kind of images we're getting here. Yeah, maybe that's a video for another time. Oh, Jojo, you have an old school 8-inch Meade LX10 Schmidt Cassegrain. Man, those are very old school. I haven't seen one of those in 20 years. Somebody's truck sounds like it's having some issues there. Try hand cranking it. I can remember when we used to use a paddle to guide. Oh man, yeah. Doing manual guiding with a hand controller and some motion buttons. Keeping the guide star centered in an eyepiece or something like that. Oh, that's fun. Got it in the late 90s. Oh, wow. When did they phase out the LX10s? They don't still make LX10s, do they? Let's see. Well, somebody's... Oh, discontinued, yeah. So it had a clock drive, mounted on top of wedge. So I'm guessing it just had a clock drive and not motion controls in both axes. Is that the deal? It's been a long time since I've seen an LX10. I forgot what features it had or didn't have. Yeah, it had a northeast-west controller. Oh, okay. Oh, so it did have northeast-west. So did it have north, south, east, west? It had all four directions you could make it move. Because I'm kind of curious then what the difference is between that and an LX50, except maybe for the digital encoders. Fun is not really the word I would remember. I remember using for it. No, those were painful times. I never really had to do manual guiding. I did it one time for a charity event, but I would not want to do that again. Definitely not a fun experience, I would agree. And trying to use, remember hypered technical pan film? You couldn't even tell if you'd done the job right until afterwards. You had to get the film developed and then find out what you got. Mr. Furious X. Pull for copyright infringement. Whose copyright now am I infringing? Copyright. You guys are still seeing the stream, right? They didn't take it down, did they? Please tell me they didn't take it down. Yeah, copyright. Copyright. Well, whose copyright? I have permission to use the music from Stellar Drone. And everything else is my content. These are my images and my telescope, so... Don't know whose copyright I'd be violating, but I'm not. I can see it. Okay, thank you, Joseph. Oh, talk about the Greenland trailer. Oh, yeah. Sorry, I thought you were talking about my stream. I mean, I've I panicked there for a moment because I've actually had that happen before, where I was doing a stream and suddenly the stream got taken down for copyright, and I didn't even know it. And it turns out I didn't violate anyone's copyright. That was Ustream TV back in the day. I assume they're still around. They yanked down one of my webcasts. I used to stream on Ustream.tv, and they pulled my webcast in the middle of webcasting Jupiter because they said they thought I was stealing someone else's content. Whose? Well, I guess they weren't used to seeing observatory images, so they thought I was a thief. I was not happy about that, as you might imagine. YouTube is usually better about that. They don't seem to preemptively pull streams just because they think that maybe there's a copyright issue, unless it's very clear. Central Florida gets smashed. I guess Disney wasn't happy. Yeah, I did see the trailer before it got pulled, and I wonder a couple things about that. I kind of wonder if maybe that's in part because with the corona stuff going around, I said it, demonetized, with everything going on, obviously the theaters are probably not going to be operating, or if they are, nobody's going to be showing up, so they probably are going to push the release of that movie back, and maybe they decided, you know what, let's take a little more time and edit it, release the trailer later, and by pulling it, I think they created hype, by artificially restricting the supply, so it creates some curiosity there as to why they pulled the trailer. So it's got people interested in it, for sure. But this comet is not capable of doing what that trailer shows, of hitting Earth with fragments of a comet. Interestingly, that trailer does feature a comet being fragmented, or experiencing fragmentation. They specifically say that this comet that's, going to hit Earth has fragmented, and I guess in the trailers, I've only seen it a couple times before it got pulled, but from what I gleaned from it, the premise is that they were expecting it would hit offshore and therefore be safe. Even if that were the case, that usually wouldn't be safe. That would create a tidal wave instead and smash the coastal cities. But in the trailer, it hits land, I guess, and smashes up Central Florida pretty bad. Like, it lands almost right on top of my house, from what I could tell. So, the movie depicts Astronomy Live being destroyed by a comet, pretty much. Yeah, fake censor to generate hype. I mean, it probably would, especially with a real comet in the sky. I bet it's a genius marketing strategy to say, hey, we can make people think there's something to this. Yeah, let's pull the trailer and hide it. Do takedown requests all over the place. Keep people from being able to upload it. They'll want to know why. What are we hiding? Yeah. They should just stick the movie online. They might get more revenue. I mean, well, they might. I mean, there's been discussions about that, about summer movies that were supposed to come out that maybe will end up straight to online, or I heard Wonder Woman got pushed back pretty far. I don't know what's even happening with Black Widow these days, but that was supposed to be another one of these summer blockbuster movies. It's going to have an interesting time, and there's discussion as to whether it's going up on Disney Plus directly, direct to streaming. I don't know. We'll see. Good, bad timing, yeah. I mean, yeah, we'll see what happens with it. I don't know. This is definitely a world-changing event, and we all just have to take it a day at a time. Huh. That's weird. Somebody pulled onto the side of the street. little bit behind my house. Well, not behind my house, but I think they're lost. Okay. He's backing out to the main road now. Yep, he was lost. He backed out to the main road and drove off. It's a little weird, though. He pulled off the side of the road at this empty lot next to my house. Wasn't sure what that was all about. They're coming for me, guys. They're coming for me. The men in black are gonna take me away. Yeah, be careful. I think it was just somebody who was clearly lost. I kind of live out in the boonies a bit, so... But don't worry, I will be safe. Yeah, congratulations, Sam. Hope everything goes okay. That reminds me. There's that meeting for that thing this week. I need to get ready for that on Wednesday. And no sweat if you can't make it, Sam. Totally get it. Alright, I'm gonna head in here for a minute, and I'll be right back. But in the meantime, I'm gonna move this window over, since the comet is moving off to the right there, as expected. It'd be really interesting to me to see what we get when we stack these images on the comet, based on its orbital elements. See if anything really comes out. Have I ever seen anything strange on the moon? No, I can't say I have. It's more like a cloud than a comet. I mean, yeah, it is very diffuse. You know, there's no real clear central portion of condensation here like there was before. And there's not a whole lot to it in general. It's just really weak. You know, at the end, before I wrap it up on the comet, move on to the asteroid, what I'll probably do is run some 2x2 bend images again and just see what comes out at sort of minimum image scale. But, yeah, I'm not seeing really well-defined separated fragments, per se. But that doesn't necessarily mean that you won't see it when you stack the images. Sometimes things come out in stacking that you didn't notice in the individual frames. Speaking of which, let's see. I don't know. You know, there might be something here. Again, I kind of see something around that position right there. That if I scroll through the timeline of the video here, just the webcast on my phone. Mosquito. Go away, mosquito. It seems like something is moving with the comet. Maybe. Could be my imagination, though. It's real easy to get focused too much on a little piece of noise. But, you know, I don't know, gang. It could be something there in terms of a fragment. Off to the side and ahead of the comet a little bit. That's interesting. That's real interesting. I'll be thrilled if I get a clearly defined fragment away from the comet there like that. I mean, that'd be really cool. The real key, the real test is going to be with the stacked image, because it's going to be stacked based on the orbital elements of the comet, unbiased, not human input on that. So if something comes out, then that means it's probably real, because it wasn't me that was seeing some little piece of noise and aligning on that noise to really make the situation worse. It's not like that. It would be, if it shows up in the stack, that means it's there. So we'll see. We'll see. I'm still skeptical. It could just be my imagination, could just be random camera noise. But what separates random camera noise from an actual signal is when you average a whole bunch of pictures together, aligned on, say, the orbit of the comet, and if something is real faint there just above the noise level of the camera, it can come out and show up. I've seen it before, so we'll see what happens. Probably the last time I really had that happen was with Comet Borisov. I didn't get any fragments, but just seeing the comet itself, it was almost impossible to see during the live stream. There's just a faint hint of something that might be there that I thought might be the comet, but I wasn't 100% sure until I stacked the images based on the comet's orbit, and sure enough, boom, it popped right out in the stack. So that can happen. We will see. Till then, we'll just monitor these live images and see what comes in. How big is the comet now compared to before? I would say it's... I mean, in terms of how much of the image it takes up, it's probably about the same. It's not a huge difference between now and then. But then again, the comet is closer to us than it was before, so it should be getting bigger in size, I guess. If anything, it might have shrunk. It's definitely way fainter, and it's more diffuse. Before, there was a really clear, bright spot, you know, at the tip of the comet where the nucleus was. We're not seeing that now. We're seeing just sort of a diffuse, slight elongated region right here. An elongated nucleus suggests that it is fragmenting or breaking up, and it's been that way. But that doesn't necessarily mean there isn't, you know, a surviving chunk of the original nucleus there that will continue to exhibit cometary activity. But I think it's pretty clear at this point that we can safely say it's not going to live up to the hype of, say, a comet that's as bright as the moon. I heard all kinds of hype. Stuff I thought was ridiculous, like magnitude -10 or some ridiculous stuff like that. I honestly never thought it would hit that bright, but I think it's safe to say now that hype is dead. That doesn't necessarily mean the comet won't be there or be visible. But as far as seeing something that's going to knock your socks off by naked eye, I really don't think this is it. The corona bigger than the sun. Oh, the coma of the comet. Really, we're not going to see the coma in this view very well, because this is still pretty zoomed in compared to a wide-angle lens that is really going to see the coma of the comet, if there is one still. Depends on if the comet's producing enough gas to really see a coma around it. But no, I wouldn't consider these images as ruling out the presence of a coma, but I'm not shooting it with a wide-angle lens tonight. I'm trying to see, what I can see as far as fragments go. If I weren't interested in that, I could throw it on the wide-field refractor and try to maximize my detection of any coma. But not really what I'm in for tonight. I have seen with wider angle views, even as recently as a day or two ago, people still able to see a bright green coma around it. But because we're zoomed in here at this pixel scale, with this telescope at this focal ratio and all the rest, it's really not going to see the coma. I wouldn't expect it to. Not what I'm going for. And I think some of those pictures that are real wide angle that you could, where the comet, what we're looking at of the comet right now becomes almost like a single point, and you're seeing a much wider angle. You can see the residual coma or just the extended coma around the comet. I hate to say it, but I feel like those images make it look a bit deceptive. They make the comet look better than it really is. Whereas here you can tell, just by comparing it to older images, there is a dramatic change in the overall brightness and diffusivity of the comet. So if you're not zoomed in enough, I feel like you don't get the full story. You get part of a story. I mean, there may still, like I said, there may still be a residual nucleus there, enough of a chunk that is still producing a coma, and it may be a hint of a tail. But that's not to say it's not fragmenting. That doesn't rule out the fragmentation of the comet. And I feel like some people fell for that and thought, well, it's perfectly fine. I don't see any change at all with my telescope. Yeah, okay, but have you really looked at the nucleus up close? Maybe not. And if you haven't, maybe there's more to the story there. So that's just my feelings, I guess, on the matter. But that's why I'm trying to look at it at this magnification, is to bring out any fragmentation, if at all possible. But even with a scope this size, we may not be seeing the full story as far as fragmentation, right? It may take a telescope twice this size to really see some of these fragments, like the picture I showed earlier. Again, for those who joined late and didn't see it, let me pull it up again. There's a picture from, I think this was last night, maybe 2 nights ago, of the comet, and you can see some fragmentation there. This is not from my telescope, this is another amateur's image, but you can see the star streaking there, and you can see the comet is being tracked, but there's something that's actually, it's not only elongated, it's coming up a little bit, it's separated clearly from the rest of the nucleus there. So there's some fragmentation going on there that you might not catch in a really wide angle view. So that's why I'm really curious to see what we get when we stack the images after tonight. Alright, so this time I promise I'm going away for a few minutes, but I'll be back. So, $2 super chat from Andrew Kroll. Thanks, we need our space. Thank you, Andrew. Appreciate it. And yeah, exactly right, Sam. There isn't enough energy in the breakup to send any part of it to Earth. And I've been meaning to do a video on that. I had hoped to do that this weekend and just didn't get around to it. Sorry. But I will do a video on that in the end. And actually, these images will help too, to be able to show the current orbit after the breakup and everything. And show what it would take to send a piece of it to Earth, because it's really dramatic. It's not coming close at all to Earth. The minimum orbit intersect distance is quite large, so no, there's no risk to Earth, and it would take quite a dramatic change in velocity to send a piece to Earth. Did I see the impact of Nigeria or wherever it was? I saw a video. I've seen videos recently claiming to show impacts in Nigeria and elsewhere. I saw one that was a massive crater in a road. That sounds to me like a truck bomb or explosives, ordnance, something. You can look at truck bombs that blew up in Iraq and stuff. Kabul. There's photos of a truck bomb that blew up in Kabul and made a very similar crater in a road. When you see a crater in a road, I mean, it's like they say, when you hear hoof beats, putting your ear to the ground, think horses, not zebras. That's not to say it's impossible for an asteroid to hit a road in the middle of nowhere in Nigeria, but it's probably a lot more likely that it's a vehicle that made a big kaboom, or something hit a vehicle to make a big kaboom. A bomb, or the truck itself was a bomb, and a really big one. So I've seen that, and I've seen another video that showed what looks like a cesium fire, or sodium or something reacting with water as it's raining, and it's lighting up. It's fire all over the place. And the material's just basically becoming more inflamed by the rain, which, I mean, it's possible, I guess, that a meteorite might have a large amount of reactive material that reacts badly in water, like sodium or cesium. Not sodium chloride, mind you, but the actual element is extremely reactive. On the other hand, somebody might have just taken a chunk of that kind of stuff and thrown it out in the rain to make a hoax video and say, hey, look, it's a meteorite impact. It's hard to say. It's very tough to distinguish those possibilities, I think, just based on looking at the video alone. So, yeah, I mean, there's more than one possibility behind these videos and these pictures. They were calculating Borisov's breakup at low velocity. And I don't know if we're talking about the same one sec. I didn't see any footage of the road crater actually exploding. I saw a blurry picture of a light at night, but it really was hard to see what I was looking at there. Maybe there's something else that came out, I don't know, but the video of it in the sky, though, no. Again, this might be a different one. I've heard of multiple reports of different things. One, like I said, was kind of a fire in the rain. The other was a crater in a road. Another was supposedly hit a building, and I hadn't seen the video of that, but maybe that's what you're talking about. Like, there's multiple in the last month or so. Streak sounds like a missile. I mean, who knows? I don't know. It could be. There's a decent video. I mean, link it to me and I'll take a look. I hadn't seen video of the actual explosion, just the aftermath. And are we talking about the road crater, or are we talking about the building that was struck, or are we talking about the one that had like a fire next to a tree? I can think of at least 3 different instances that have been reported, so I don't know which one we're talking about. We might be talking at cross purposes here. Yeah. It is the internet. Grains of salt needed. For sure. I get the question sometimes, though, you know, are fireballs increasing? Are there more fireballs this year than previous years? Yeah, put it in the chat. Put it in the chat. I'll take a look. And so I actually, not that long ago, wrote a program to, because that's what I do. I wrote a program to show the number of fireballs for the last few years using NASA's Asgard monitoring system. It's a series of webcams, all sky cameras, positioned around the country, around the United States, that actually measure the orbits of these fireballs based on the parallax of the streaks of the fireballs as they come in from these different sites around the country. And so you have a fixed number of cameras and an objective measurement where it's not just looking at the number of people reporting something, but actually the number of detections on a fixed system. And what you see is the background level of fireballs is very consistent. You have spikes. You definitely have spikes when there's meteor showers, but the overall level hasn't changed. So I just dropped a link to that in the chat so you can see that. Who's that to, Valiant? Valiant Regal, you need to look much closer to Earth. Not sure what that's referring to. Or maybe it's just a comment about what might have caused that explosion, something much closer to Earth. Could be. Guilty of that one with the AMS fireball site. Exactly. That's the one I see most commonly cited as proof that the number of fireballs is increasing, because the number of reports is increasing year over year consistently. Like, if you look over the whole last 5 to 10 years, it's every year it goes up and up and up and up, because the number of reporters are increasing. The number of people reporting it to the AMS website are increasing. More people are hearing about the AMS website, so more people are reporting. But if you have a fixed number of observers, like cameras that observe the sky all night, at a fixed number of sites, what you see is a very fixed number of fireballs in terms of the overall background level. Now, from meteor shower to meteor shower, and year to year, you'll get variations in the density of the stream that Earth flies through. I think one sec, you mentioned that just a moment ago. Meteor streams we pass through every year have varying densities. I've heard of 10,000 per hour at times. Yes, exactly. So sometimes you'll get a meteor storm from an annual meteor shower. But if you ignore the annual meteor showers that produce these large spikes, and you just look at the background level between meteor showers, it's very consistent. Can we see your link? No, we can't. Tell you what, Greg, I'm gonna take a chance on you not messing up my stream here, my chat. I'm gonna add you as a moderator temporarily. So now you should be able to post the link. I'm sorry you weren't able to before. I don't seem to have a way of changing that. Maybe, no, I'm in live chat, not top chat. You should be able to post it now, so give it a shot. Okay, thank you. Alright, take a look here. Okay, I see the road crater. Okay, and I see what looks like a fireball or bolide. But I thought, I've seen that video before, and I don't know why, but I didn't think that was the same night that the explosion happened in Nigeria. I mean, that video might be from Nigeria, but are we sure that that actually happened the same night? Let me see if I can find the original source at Bill Gillen. There's their TikTok. Man. You kids and your TikTok. Okay. 192.4 thousand views. Okay. How do you even... I'm not familiar with TikTok. To be fair, I don't know much about TikTok. I'm not on TikTok. I'm not hip like that. How do you tell when this was posted? How do you even... Original source Bill Gillen, I guess is what that means. Original. Great, but... how do you find out when it was posted? On TikTok, there is no time. Popular app doesn't tell users when a video was posted. I don't like this. Yikes, that is a yikes. So there's literally no way to even tell when it was posted. All we know is it's a video of a bolide or a meteor. Really bright one, slow, relatively. It's a really impressive video, no doubt. And it does look like a meteor. Maybe it's even the one that caused that crater, for all I know, but... I really do not like TikTok now. Okay, well... Learn something new every day. Apparently on TikTok, you can't find the date something was posted. No time on TikTok, yeah. I am not a big fan of TikTok then. Note to self. Never use TikTok. Yeah, no problem, Greg. Thanks. Thanks for posting that link. And remove moderator. Sorry, we're trying to keep a... I'm trying to keep a lid on who's a moderator these days because some other friends of mine have been having issues with rogue moderators going crazy and just destroying live streams and stuff. So there's rogue mods out there who are seeking to do damage to myself and friends of mine. Nothing appears in CNEOS fireballs since March 4th. Which makes me pretty suspicious. Well, maybe, I don't know, maybe that's got something to do with the shutdown, the quarantine and stuff. I don't know. Let's see. I see what you mean there. Yeah, nothing since March 4th. GLM bolides provides the data for these detections. Okay. Oh, well, we've got... That's interesting. Okay, so CNEOS is not updated, but it looks like we've got something even 6 days ago on the Bolides website, so I'll post a link to that. yeah, it'd be interesting to see if there's one. And I've forgotten when that Nigeria thing happened with the road. Be interesting to see, though, if there's a bolide for that particular day and location. A little tough to do the research while I'm also doing the stream here, but here you go. Here's the bolide's website. You got shadow banned by Rogue? Was that on my channel, Andrew, or somebody else's? Yeah, SlickX. I don't know who it is, but Red actually was the one that warned me that I need to make very sure that I don't have anyone I don't know moderated, basically. If I'm the slightest bit uncertain about anyone, don't give them a wrench or take away. I took away wrenches the other day because of that. Trying to tighten up the hatches and make sure it's all secure. So yeah, Atlas is definitely fragmenting, Watson. If you're late to the stream, I'll share an image again. This is from another amateur, just showing. That's what it looks like as of a night or two ago. You can see how the nucleus is not only elongated, but there's actually a stream of material or a couple of nuclei, a couple fragments pulling away from the main nucleus. So there does seem to be some fragmentation going on there. And I've seen other images like that as well. It's not just one observer or one telescope reporting that. But they are generally using scopes larger than mine, so I don't know how much I'll see in my stacked image at the end. Oh, it was over on Steve McRae's channel, was it? Yeah, I heard he had real big problems. March 28th. Okay, so that was the date of the road crater, I assume. We can scroll down on the bolide site. I mean, there's bolides all over the place. March 31st, March 30th, March 29th, March 28th. And do we have the coordinates of where that was? What? Can you give me the latitude and longitude of where that occurred? That would be helpful. I assume these longitudes are in east. Oh yeah, it shows actually on the map where they are. Okay, so I'm looking at March 28th. I see two bolides mentioned. One near South America, one just off the coast of California. So neither one are over Africa, but I don't know if this site provides coverage of that region of the world anyway. This might just be Pacific, South America, Pacific. You know, I'm kind of feeling like this is not covering that side of the world anyway. So I don't think it's really conclusive one way or the other. It just seems to cover sort of out to the Atlantic, maybe. Oh wait, we got one over there in New Zealand. G17. I don't know what G16 and G17 refer to. Those must be satellites or something. But I don't think either one of them are positioned over Africa, it feels like. Because I'm not seeing any bolides over Europe or Africa or anything. So, yeah, I don't think that's conclusive one way or the other. Unfortunately. Oh, you got a date on that TikTok video? Thanks, Sam. I don't know my TikTok. Sorry. Oh, well that that answers that, doesn't it? Okay, thanks. So Sam in the chat just sent me a screenshot of the TikTok date for that video. Sorry, gang, that is August 2nd, 2018. So, a little bit old, and definitely has nothing to do with the road crater. I kind of had a feeling that was going to be the case. Just because I know I've seen that video before. I probably saw it a long time ago, is what the deal is. Well, there you go. Thanks. It was a team effort, group effort, but we did it. I think we answered that question. At least we know that video of a fireball had nothing to do with the road crater. Yeah, the map is worldwide, but I couldn't find any examples of bolides on that site that were covering Africa or Europe. So I don't know if, although it might show the whole world on that map, that might be deceptive. It might not actually have worldwide coverage. I don't know. But at least we know for sure that TikTok video is a distraction or just unrelated to that other incident. So thank you again, Sam, in the chat for providing us with that date. Okay, so the Fireball CNEOS site uses several sources. One is the lightning mapper, which is Western Hemisphere. The DSP satellites provide the others. Yes, okay. So, DSP satellites should have worldwide coverage. But, like I said, CNEOS doesn't seem to be updated lately. Have the conspiracy people? No, I think, well, you know, that's a good question. I haven't looked today or this weekend even, how many Comet Atlas videos there are, and how many of them are nonsense versus how many of them are real information. Kind of curious, actually. It looks like Astro Addict uploaded a video 10 hours ago. How I photographed a dying comet. That's cool. This week. You know, lately, YouTube has, you might say, done a good job or whatever. They've definitely changed their algorithm to try to suppress conspiracy videos. And it does seem like it's harder to find those kinds of videos. At least they're further down in the search results. I don't know whether that's purely due to their popularity or due to algorithm changes. There are still, oh my, yeah, if you scroll down far enough, you hit the bedrock of nonsense. Somebody claiming to upload Comet Atlas debris, which is clearly just a bright star that's out of focus on like a standard camcorder or other point-and-shoot camera. It does not look to be the comet at all. Jeez, there's a ton of those videos. All from one channel, yeah. So, yeah, I guess there's that stuff. My goodness, there's no shortage of that stuff. But, I'll be addressing that on the EIE network later this week with Red's Rhetoric, so go check that out. We're going to do a breakdown of various Comet Atlas videos. Will 1998 OR2 hit? Well, we're going to go find out ourselves. The answer is no, at least according to the official orbit. But, yeah, I'll be doing my own independent orbit determination using nothing but my own observations of 1998 OR2 in order to head off those stories, because that'll be next. Even if this comet completely fades out and we all lose sight of it, and nothing is ever heard from it ever again, they'll just move right on to making stories about 1998 OR2, which is flying by Earth later this month. But, no. Spoiler alert. Everyone's saying in the chat it won't. You're right. Exactly right. It won't hit Earth. Neither will Atlas debris. No. Yeah, I'm not even sure quite how to read that latest comment there from ABS Sky Motto. It's because of pole shifting of Earth and that attracts comets? I don't see what Earth's axis of rotation has to do with attracting comets. Don't think that's how that works. What do I think about the EU guys in the Sapphire project? If that is referring to Electric Universe, that's a whole nother can of woo. Doesn't work. And it's varying degrees of wrongness, but no. But surely the official sources are just paid shills trying to cover something up. Exactly. Exactly, Sam. That's why I have to collect my own independent observations to blow open the lid on the truth. You can't handle the tooth. This chair's not as comfortable. Unfortunately, I spilled ice-cold water on my favorite lawn chair tonight, so I'm in my second favorite lawn chair, which is second by a wide margin. Not as comfortable. We are protected by magnetic pole shift of the Earth. Well, the magnetic field protects us from the sun's radiation, protects our atmosphere from being stripped away by solar wind, but doesn't really do anything to protect us from comets. So, what does this all mean? We will have threadfall soon. Is that? No, wait, that was timefall. I was thinking of that new game that came out. What's it called? Death Stranding. Yeah. Sam, Solly, for $2, you can't handle the truth. Exactly. Let's get Jack Nicholson in here. Oh, you found a stony chondrite, Renee? That's cool. Eye telescope is shut down because of weather, as usual. Yeah, that does happen. I was glad that at least New Mexico was open for business for the flyby of Bepi Colombo. You guys can go check out my video on that. Time-lapse of the images I collected there and analysis of the orbit. So I was working on that this weekend. Threadfall is from Dragon Riders of Pern. Oh, okay. Wasn't familiar with that one. Yeah, no BS here. This is the no spin zone, right? This is the no astronomical BS zone. Do I think there's a firmament? Well, somehow people got it into their heads that firmament means physical dome, but I mean, other people refer to the firmament as just the sky. I don't know if the rumor is true, but the story goes that Werner von Braun's tombstone has the word firmament written on it. I don't know that that's actually true, but that's what the flat earthers say. But even if that's true, Werner von Braun didn't think that there was a physical dome over the sky, just that that was another word for the sky. So, if Werner von Braun put that on his tombstone, I guarantee you it's not because he thought the Earth was flat. Varric Bostrom for $10. A whole other can of woo. Yes, thank you. And MNMB 3640 $3.99. My 2 favorite space objects this month. Oh, thank you. Yeah, we will move on to the asteroid shortly. I want to get it before it gets too low. It's 11 o'clock now. So, let's see here. Oh, something's playing in the background, I think. Oh. Thought it was, anyway. Let's see. Where's that asteroid at? 1998 OR2. Oops, I typed it wrong. It's at 53 degrees above horizon. Yeah, we're going to need to move on to it pretty soon here. What do we got for guide stars there? Man. OR2 is hanging out with no good guide stars. What's going on there, huh? Magnitude 10. Okay, we're going to have to settle for magnitude 10 for guide star. That's going to be another one of those 1 second guiding pulses things. Well, maybe I can get that one. Oh yeah, magnitude 8.9 if I rotate the camera. Okay. We can do that. Let's basically go 90 degrees on the camera rotation. That'll work. Okay. So this is one of those cases I'm going to have to rotate the camera, recalibrate the autoguider again. But I can make that work. Yep, we will do it. Alright, what are we at now? We are on image 42, which is the answer to life, the universe, and everything. So I think on image 42 we will wrap it up on the comet for tonight and move on to the asteroid, 1998 OR2. Yeah, there are some observatories being closed from what I've heard. I've heard rumors about that, and I think I mentioned that on a previous webcast. Man, is my tablet making noise? I think something's making noise here. Yeah, the tablet just had the tiniest bit of volume up there. It was irritating. There are going to be some observatories closed because, for one thing, a lot of these observatories are in very remote locations. And they don't want to have to divert emergency resources if somebody gets sick or injured or whatever. Oh, hey, we got a satellite going through there. That's cool. Unexpected. Especially at this hour. So there you go. Perfect timing there. Image 42, answer the life of the universe and everything. We got a nice unidentified satellite streak going through the view. Let me see if I can look up what that might have been on Sky Safari. Maybe some sort of polar sat. But Sky Safari's satellite database is far from exhaustive. It's not super duper thorough, so there's a pretty good chance I won't be able to find out what it was. Show satellites. Wait. We have an ID. Oh, yeah. Stop it. Stupid mosquito. There was a satellite that passed very close. Rapid Eye 3. Rapid Eye 3. That's probably what that was. It flew right through just about the time that image was taken. That name rings a bell, too. Was that one of those Google satellites or something? One of the ones Google uses for... No, it's a ESA. Rapid Eye was a German geospatial information provider focused on assisting in management decision-making through their services on their Earth observation imagery. Here we go. The constellation consisted of the following satellites: Rapid Eye 1, Rapid Eye 2, Rapid Eye 3, 4, and 5. All 5 satellites were launched simultaneously on a Dnipro rocket, not sure how you pronounce that, in August 2008. They all share a common orbit. No, it's definitely a Russian rocket right there. And they are all separated in orbit by 19-minute intervals. They were the first commercial satellites to include the red edge band, which is sensitive to changes in chlorophyll content. So yeah, these are basically commercial Earth-sensing satellites. So smile and wave, boys. Smile and wave. We've got eyes in the skies over us right now. Alright, cool. Well, that was nifty neato. Wasn't expecting that, but definitely makes for a cool final picture there on the comet. Sounds Ukrainian. Maybe that's a Ukrainian name. It looked Russian to me, but I couldn't tell you the difference between Russian and Ukrainian. Alright, so let's move on to Asteroid 1998 OR2 now. So I'm going to have to reorient the camera. And then... No, I don't want to go to Rapid Eye. I want to go to the Asteroid. And then I'll have to recalibrate things. Let's see. What would be a good... I need a good focus start anyway. I'm going to have to refocus the telescope when I slew over to the Asteroid. Looks like Pollux will still be the best place to do that. So I'm going to slew it over to Pollux now, refocus, and recalibrate. Meantime, before I forget, let me change this. We're going to be doing 1998 OR2. Oops. 2. No, let's not have a space in there. We'll make it all one word. Easier to deal with in Linux. Okay. And we're not going to save it just yet because we're going to be refocusing. So we're going to need that. We're going to need that. Like that. Okay. Cool.
mierda es eso? ¿Qué es eso?
So it's a very good thing there's a little bit of wind tonight. I totally forgot to put on my dew heaters. Fortunately, I just looked at the front corrector plate of the telescope and there is no dew formed on it. Because we got a little bit of wind in the air tonight. It's actually keeping everything dry. Lucked out on that. I don't know how I forgot to do that, but I did. Let's see how the focus looks. Actually, we're still in perfect focus. Beautiful. That doesn't need anything at all. Okay, I am going to have to reorient the camera, though, and recalibrate. Let's see how she looks now. Oh, no, not subframe. 2x2. Take an image. Okay. I'm going to double check the focus now that I twisted the camera. It should still be at the same distance from the mirror. I mean, the focal length should still be exactly the same. But if it's even just a hair off, it will make a difference as to the focus. So let's check and see. Yeah, it's a hair off. Okay. Just needs a little bump. Unfortunately, I'm not sure what direction it needs a bump. I took a guess. I think I guessed right. By golly. Yep, that looks pretty good. Maybe just a hair more. I might have gone too far, just a smudge. I'm just really fine-tuning it just ever so slightly here. Never quite satisfied, am I? Okay, that's good enough. I guess I'll call it I don't know. Yeah, just a bump. Because if I get to the asteroid and I'm not happy with the focus, I'm going to be mad at myself for not fine-tuning it just a hair more. A little bit of time investment now will pay off. Okay. That looks good. I'm going to say it's good right there. And even though there's no hint of dew forming right now, I am going to strap on the dew heaters before I go any further, just in case the wind calms down. Good news about being surrounded by trees on all sides is even when it's a fairly windy night, you really don't feel it. Trees are acting like a wind block for the telescope. Alright, subframe. No, we don't need subframe. We want 2x2 binning. Okay. So now we're going to go ahead and calibrate the auto guider. Okay. Calibrate. All right. Didn't mean to kick on the music that loud, sorry. How can we see your setup? Well, I'll tell you what, after I get the asteroid tracking going, I'll throw my Google Pixel out there and take a picture of the setup as it's tracking the asteroid, and I'll share that on the stream. Okay, drive calibration successful, it says. Need to make sure it's symmetrical on the y-axis. Now we calibrate the adaptive optics. So I've rotated the camera to maximize getting a good bright guide star for tracking the asteroid. Let me go ahead and get the asteroid's current coordinates pulled up. Okay. Oh wow, and a huge donation from KLRB. Happy Easter. Happy Easter. For 1,250 Filipino dollars. Alright. Let's see if I got lucky or not. Wrong imager. Okay, didn't really get lucky this time. Let's see. Well, thank you for that huge donation. Actually, I did get lucky. That is the star I'm looking for, isn't it? It's not quite as bright as the last thing, I guess, but, well, it's pretty bright. Magnitude 8.9. That's decent. So I just need to position that where I want it. Filipino pesos. Philippines pesos. Well, thank you very much. That is very generous. I'm sure that's a lot of money. Okay, auto guide begin. Alright. Cool. We've got auto guiding going there. We're going to auto save these images. We're going to go to 1x1 binning. And we're going to run 60-second images. Alright, here we go. First image of Asteroid 1998, OR2. Alright. Stars are looking nice and tight. Let's see if I can find the position of the asteroid. I'm trying to get my bearings here. Okay. Definitely in the right region. I'm thinking is it all the way down there? Might be. should move up and to the right in the view. Oh man, the wind is hitting my microphone. Sorry about that. I don't have a wind block on this thing. It's usually still. Usually we don't get too much wind. Okay, downloading image. Let's see if it moves. So if it moves, shoot it, right? Yeah, I think it did. I think it was this one. Yes, thank you, Andrew. I don't have a 3D printer, and unfortunately I don't know anyone who does, personally, but if you do have one, consider helping out by printing out some parts there. Am I outside? Yes, I am. I'm at the telescope. I definitely need to be present to watch this telescope in case it decides to go crazy. During my last live stream, the declination cable, which is a bit broken, came loose and caused the motor to go into a runaway state, which it will do if the cable comes loose, but it still has voltage applied. If it doesn't get the signal for what it should be doing, it will just start driving, and it will drive the scope until it yanks out a cable or destroys something. So I need to keep a close eye on things. Yep, I can see it moving. There it is. There's 1998 OR2. Asteroid that will be flying by Earth later this month at a distance of about 16 times the distance to the Moon. But some people, particularly conspiracy channels on YouTube, etc., are making claims that maybe somebody's covering up something about this asteroid. Maybe it's actually going to hit Earth. Well, we're going to figure that out for ourselves with independent data. So I'm going to be calculating the orbit of this asteroid using the observations from tonight and from previous webcasts where I've collected images of the asteroid. And I'll be solving for the orbit myself. So you can see it moving quite rapidly here from image to image, even with just 1 minute exposures. I'll be making a slight modification to my astrometry program in order to collect the coordinates of this asteroid over time and solve for the orbit. And I'll be uploading an updated version of that to GitHub as well, along with a video analyzing this object and its orbit. How large is this asteroid? A little bit more than 2 kilometers, I believe. If I remember right. Yeah, spaceweather.com has it as about 2,457 meters in diameter. So almost 2.5 kilometers. It's easily the largest asteroid coming close by Earth anytime this month. Well, the Yarkovsky effect can change the orbit of the asteroid over time from the heat of the sun, but that's a gradual, small effect. That's not something that's going to suddenly send this thing from being 16 times the distance to the Moon to 0 times the distance to the Moon in a matter of days. That just doesn't happen. We're talking about long-term perturbations to the orbit. But the orbit of this object is extremely well known, which is why it's a numbered asteroid. We understand the future trajectory of this asteroid pretty well, at least for our lifetimes. So over hundreds of years, then yes, it can perturb the orbit, but over a few days, not enough to notice. Yeah, you will see a good jump in the position of it from image to image. It's trucking right along, as expected. Man, the wind is really whipping through the pine trees tonight. You can hear it. Hopefully it's not hitting the microphone too directly. I'm going to try to turn the microphone away from the wind. It's not helpful. Sorry about the wind. Whole lot I can do about that right now. It's just so windy. That's the other advantage of the adaptive optics system. It's so fast at responding that it really keeps these stars as nice pinpoints, even with wind, even with pretty severe wind that you can hear on the microphone. The stars are still pinpoints. This wouldn't be the case without the adaptive optics system that's rapidly performing guiding on this guide star here at like 4.5 hertz, thereabouts. Yeah, 4.1 hertz currently. 4.2, 4.1, somewhere around there. So a little over 4 corrections per second, so it's able to compensate even for perhaps some residual shake from the wind. The background music is Stellar Drone. You can go check that out. He's pretty easy to find, and music is definitely used with permission. So while that asteroid trucks right along, I'm going to go inside for a bit, grab a bite, and I'll be back afterwards.
Mierda, es eso. ¿Qué es eso? ¿Qué mierda es eso? ¿Qué es eso? ¿Qué mierda es eso? ¿Qué es eso? ¿Qué mierda es eso? ¿Qué es eso? ¿Qué mierda es eso?
That's weird. I just went inside and noticed there was like a loop of audio playing from the microphone. I'm hoping turning on the microphone and turning it back off again will fix that. I guess we'll see. gang. Sorry for the long delay, but ran into some unexpected problems there. Nevertheless, the telescope is chugging along just fine, it looks like. For anyone joining late, we're currently tracking Asteroid 1998 OR2. You can see it right there, moving along relative to the background stars. I'm going to be collecting the astrometry and measuring its orbit using nothing but my own observations over the last few weeks. So I'll be doing a video about that, and a video time-lapse of the last couple of nights of webcasts I've done of Comet Atlas, and stacking those images to see what we get. So stay tuned for that. Also, right now, going on is the 50th anniversary of the Apollo 13 mission. And I tweeted about this, but for anyone not on Twitter or not following my Twitter, I highly recommend the website apolloinrealtime.org/13. You can go watch a real-time replay of the audio and video from Apollo 13, the actual audio and video from all of the mission control stations. I watched the launch play out in real time on that site, and it was incredible. It was amazing to see all of that happening, 50 years to the moment that it happened. And so go check that out. You can watch the whole mission play out from beginning to end in real time, and you can focus in on a particular mission control console and hear what was going on. So you can hear the Capcom loop, you can hear ECOM, FIDO, all these acronyms that you might have some passing familiarity with from watching the movie Apollo 13. But this is the actual audio and what really happened. And I think you'll find the truth and the actual mission recordings to be quite informative and, in my opinion, more interesting than the fictionalized movie. I have to say, just watching the launch process play out made me irritated slightly at some of the liberties Hollywood took in making Apollo 13 the movie. Because in some ways they tend to add drama to things that weren't quite so dramatic, or the way that they do it tends to dilute the professionalism of these astronauts. I'll give you a concrete example here. In the movie Apollo 13, they show how Ken Mattingly was replaced by Jack Swigert on the backup crew. And that really did happen, but in the movie, they depict Ken Mattingly as kind of being depressed and mopey about it. And, I mean, clearly upset about it, but more than that, he's kind of feeling sorry for himself. They show him watching the launch, and he's happy for his friends going up. But then he kind of... they imply he gets drunk in a hotel room out at the Cape, and they have to wake him up when the accident happens. Okay, real story. As you'll see on the website, Ken Mattingly was not at the Cape watching the rocket launch and feeling sorry for himself. No, he was in mission control when the rocket launched. That's in Houston. He was in Houston. He wasn't driving up to some random spot on the Cape in his Corvette just watching the rocket launch and not being helpful to anyone. No, he was assisting even then, before the accident, in mission control during the launch. And just seeing that contrast of what really happened versus how Hollywood tried to make it more of a human story, more of an interesting story from the human side, it kind of rubbed me the wrong way. I mean, I knew that they took liberties with some of these things and depicted the crew fighting and sort of infighting in ways that they didn't really. But this also showed it to an even greater extent, to really see the contrast between what actually happened versus the way it was sort of played up in the movie. So check that out, check out that site, and I think you'll enjoy it if you're a space fan like me. So my Twitter is @AstroFerg on Twitter. good night, Backyard Astronomy. Hope you enjoyed the stream. I'm going to be wrapping up here, too, myself. I've got to get some sleep here, so... In just a little bit, I'll be wrapping up the webcast. I think we'll try to close it out after getting a full hour of light on this asteroid. So, if you're joining late, the asteroid's moved up right here in the view at this point, and you'll see it moving every time a new picture comes in. It'll move slightly up and to the right every 60 seconds. So we'll get another 4 minutes of pictures here and then wrap it up for the night. But I'll try to answer any questions here in the chat while we do that. "50 years, yeah, 50 years from Apollo 13 now. And I'll just post my Twitter handle there in the chat so you guys can go follow me on Twitter. I don't tweet that often, but sometimes I'll try to give a heads up about webcasts and things, or cool links that I find, things like Apollo in real time. Why are all the observatories closed? Well, they're not all closed. Some of them are still quite operational, including Atlas, by the way. Atlas is the name of the observatory that discovered Comet Atlas, of course. It was named for the observatory that discovered it. It's not the only comet that they've discovered, and is thus named Atlas. And Atlas, the observatory, is still open, still taking pictures. You can actually see the pictures it's taking. And I'll actually pull up that site now. That's a good idea. Let me see if I can find it again. Let's see, looks like they are... Wow, looks like it might be condensation around the lens, the sky lens. Anyway, it's not... yeah, it looks like it might be cloudy and not so good weather, but I did see it yesterday. I think they were open. And there's 2 sites in Hawaii. It looks like they're both going to be cloudy today. But I'll post links to the chat to the 2 Hawaiian Atlas sites. And you can actually see the all-sky cameras. You can see what the conditions are. So clouds, bad, not safe to open right now. That's the status at the moment. But you can check back the next day, and keep an eye on it. And then I think it was the Mauna Loa site, MLO, that discovered the comet. I think it was that one. I'll have to look and see. Now I'm curious. Which one was it? There were 2 of them there on Hawaii. Planet Center. Yeah, I want to see the orbit observation database on C2019Y4. Yeah, it was MLO that discovered it. So there you go. There were actually some pre-discovery images found on the Catalina Sky Survey, it looks like. But MLO was the first one to actually discover it. So there's a link to it in the chat. It was the second one I posted a link to, I think. Yeah. So you can check that out. And when they are operational, when they are open and taking images, you can see the latest images that they've taken down there at the bottom of the page. So. No, we're not going to go through the comet's tail. The comet's tail points away from the sun, and the comet is not passing between us and the sun. It is roughly passing between Mars and the sun, so the comet's tail would be pointed at Mars at about perihelion. And I'll take a look at Mars when that happens, even if we can't see the comet at that point. I'm not expecting to see Mars devastated by debris or explosions on Mars or anything like that, but who knows? I guess we'll see, right? I'll keep an open mind, which is why I will take pictures of it. But no, a comet's tail is not a threat to us, and it's not pointing in our direction. Alright, so one more picture here of Comet Atlas. Oh, TO8. I thought it was, yeah, it was TO8. Okay, yeah, you're right. So that's the MPC code for Atlas MLO. Is it possible for the guide cam and mount to interfere with each other if I have selected ASCOM control in PhD2? There's a PhD2 now? Oh boy. I haven't kept up with these things. I haven't used PhD in a long time. I did used to use PhD. But also have the ST4 cable hooked up as well. Good question. Guide cam and mount to interfere with each other. So you've selected ASCOM control in PhD2, but you also have the ST4 cable hooked up as well. I guess it depends on what guide camera you're using. If it's sending guide pulses through the ST4 and you're also trying to control it through ASCOM and PhD2, ASCOM control would generally imply that you're using an RS-232 port to the telescope as well. I wouldn't try to drive both of those things at once. I would only plug in one at a time and use that. Because, yeah, I could see how the guiding pulses should theoretically... I don't know why that is, but I feel like those would occur faster than the RS-232 serial port control. There might be a little bit more lag in the serial port control, I'm guessing. So you may get some feedback or some oscillation there. I can definitely see how that could cause a problem, maybe. I wouldn't do both at the same time. No, it's no big deal. I mean, I've never tried to do it that way before. I've never hooked... I do have an attic camera that has an ST4 port on it, and I usually use that with just PhD guiding, because I could never get the ST4 port to work with PhD. But the RS-232 control would work just fine. But yeah, I wouldn't hook up the ST4 if I was using RS-232 through PhD. For anyone who doesn't know about telescopes and guiding, everything I just said is gibberish, but I think Backyard Astronomy knows what I'm talking about there. And just for those who do know telescope ports and PhD guiding and all that kind of stuff, what I'm using right now is CCD soft with the AO7, and the guiding pulses do go through the scope through the ST4 port on the LX200 Classic. So I've got a port that's labeled CCD. That's what's hooked into the camera, but it's actually hooked onto the ribbon cable that runs between the camera and the AO7 adaptive optics unit. So the software will send guiding pulses when it's needed to keep the guide star within the range of the tilt of how far the mirror can tilt. And I see now I'm a couple of minutes past when I said I was going to stop, but keep going here just to explain this. So the telescope will move its motors to keep that guide star within the range of the maximum range of tilt of the mirror. I'm at 72% in the x-axis, 30% in the y-axis. If it were to bottom out at 100% or 0%, that means the mirror can't move any more in that direction. So it keeps it within the range that it can travel by using the motors occasionally to provide guiding pulses through the ST4 port, which is a standardized guiding port that is built into the telescope to receive guiding pulses that tell the telescope's motors, I need you to move to keep the stars centered. But I'm not using it to keep the star centered, I'm using it to keep the star within the range of travel of the tilt-tip mirror. The tilt-tip mirror is actually doing 99% of the work. It's keeping that star centered every time it takes a picture at 4 times a second, that little star here on the left. So it's monitoring that star and making sure it stays centered, using the tilt of the mirror to compensate very fast for any tracking errors, as well as any wind, any atmospheric turbulence that might shift the position of the star. All of those are being compensated for 4 times a second by the AO7. The motors of the telescope are incapable of responding as quickly as the tilt-tip mirror. So it's a interesting hybrid system where it's using 2 different things to keep that star centered. But one is the telescope's motors, which are only receiving an input from one cable, and then the other is the AO7, which has a ribbon cable that runs between the camera and the AO7. And I guess, let's see, how's that work? Where's that cable? Wait a minute, where's that ribbon cable go? Because I plug into the... Man, I've forgotten how that... There's a whole crazy wiring thing. Okay, yeah. It's like a... It's a strange connection. So you got a ribbon cable that runs between the camera and the camera's guide port and the AO7. But then another wire plugs into the midway into the ribbon cable and taps into that and goes between the telescope and that ribbon cable. It's a whole crazy thing. So yes, I will do a time lapse and stack the images, and I'll upload that as a separate video afterwards. And then I'll do another video on the Asteroid 1998 OR2. I might fold that into the video I was planning to do on what it would take for debris from the comet to get to Earth, and how ridiculous that is. I might do something like that so that I can address 1998 OR2 in that as well, and show what it would take for 1998 OR2 to be diverted into an Earth impact trajectory. Make sense to you guys? Okay, good. I'm glad I made some sense to some people here. So, yep. What's my recommendation for a commercial telescope to use your sat tracking software? Thinking 6-inch Cassegrain type aperture. So for satellite tracker, I haven't extensively tested it with Nexstar. I have tested a bit with Nexstar, and I like how it works. The Nexstar mounts, for just basic satellite tracking, I think a Nexstar mount would be fine. But I do want to do some more extensive testing on it and really try to shoot ISS through my Nexstar. My Nexstar telescope is only a 4SE, whereas my Schmidt Cassegrain, the OX200, is an 8-inch. So I always am too tempted to just use the 8-inch because it's a better telescope, obviously, for shooting ISS. But one of these nights, I'm going to have to sort of sacrifice an ISS pass to the Nexstar just to verify it really does work well. Because I've tested the sat tracker software with the Nexstar, but only with the Finder camera. I haven't really shot satellites through the Nexstar itself while using sat tracker, so I want to verify all of that and make any adjustments if necessary. So I don't want to commit to say you should run out and buy a Nexstar just for my software, but I think a Nexstar will get the job done quite well. So I hope that answers your question. The Celestron Nexstar, pretty good scope because they really do open up the software for direct drive rate control, and I hate to say it, a lot of the lower end Meade scopes don't do that. The Celestrons do, but Meade does not until you get to the OX200 level. So, alright, I think that's gonna do it for tonight. So thank you all for coming. Thanks everyone for watching. Stay tuned for more videos. If you haven't already, please consider subscribing to get automatic updates on when I'm going to do webcasts, and also hit the bell for notifications for when I post my time-lapse videos and stacked images. Thank you all again for watching. Thank you so much for all of your support. Keeps my telescope running and keeps me sustained to be able to buy replacement parts for it when things break down, because they do break down. Next step, like I said, I still got a cable that needs fixing. Not an expensive repair, but just got to get the time to do it. So, thank you all very much. I'll try to get the stacked images and time-lapse uploaded sometime in the next day or two, so check back for that. Until next time, clear skies.